Okay. Hey, are you back with me? Always. Good. I wanted to ask you about the bloom. Okay. I've been trying to understand what is causing it. It seems unlikely that we are looking at a stable ecosystem. It has to be a unique event. And yet, creatures have rapidly and effectively adapted to these conditions. How is that possible? There's something we aren't seeing, something Monet was investigating too. Do you think she knows something we don't? Probably. She has to. Maybe she's holed up in the lab mentioned in the map data waiting for us. Let's find that lab. Hell yeah. Okay, so keep you. Not you. And then... and then you. I need to get more of these bivalve shells. Okay, yeah, just hold on to one of those. Oh wait, no, this one? Yeah. So, I'm gonna go to the lab and look at some taxonomy. And the animal novae. Brachiomorph, gill fans, bloom fan. Bloom fans are delicate and pale fan-shaped creatures that filter the toxic microbes of the bloom. As tall as a human and with wide span of pale spines that form a feather-like shape, they are instantly recognizable in the green clouded water of the bloom. Anchoring themselves into the sand with a central stem, the bloom fan's filtration leads to a small patch of oxygenated water in the leeward side of the fan. Bloom fans seem to be sensitive to currents, adjusting their angle for better catchment of microbial growth, and also can often be seen shivering in order to free their delicate filaments of bloom growth. How they contend with the high toxicity and deoxygenated water of the bloom is unclear, but perhaps analysis of the dust that coats their spines may offer some clues. Did I? Oh, you know what? I didn't actually do any of the... It was you, right? Yeah. Analysis complete. Bloom fan taxonomy entry updated. Okay. Oh my god, shots don't start shit. Shut up! A close analysis of the fan dust shows that the fans catalyze. I swear to God. Catalyze the bloom's microbes into... Why when I just start talking again? Are you gonna do it again? Because I'm gonna go back to my game. Nothing is wrong with you. Or everything that's wrong with you. The close analysis of the fan dust shows the fans catalyze the bloom's microbes into massively increasing their oxygen production, to the point that the cells themselves are torn apart by the oxygen that bubbles out from within them. This is why bloom fans can be heard to be fizzing when in close proximity, and suggests that oxygen is the primary nutrient that the fans acquire from filtering. Interestingly, this analysis suggests that the bloom's microbes are oxygen producing by nature, and maybe a form of algae? It is only their sheer density blocking their access to sunlight, which means they no longer produce oxygen, but instead choke and poison the ocean. Meanwhile, it seems unlikely that the fans live on oxygen alone. What other nutrient sources might bloom fans used to support themselves? Fascinating stuff. Right. Okay, so we are over here now, and we need to go over here. Signal priority data from the way station places Monet's remote lab in the southern part of the bloom. She's hiding something here. Alright, does that mean that that whole area... I mean, there's still stuff we haven't done over here. Yeah, I'm wondering, maybe we should just take a detour real quick and try to get some of these other samples taken care of. Okay. Okay. So, if I go... There was a place down that way. I should probably pick stuff up, shouldn't I? Yeah, I don't have any sea spores. I should go. Can my drone pick me up out of here? No. It cannot. Bright pollen. No, I don't need bright pollen. I need sooth spores. This is also bright pollen. Yes. Alright. Come on. Alright, so let's say up here there's a doodad. Okay. Not. Come on. Thank you. I don't know how many shrill sacks. Okay. And I still can't go, but if I turn on my propulsion... Yeah. Come on. You can do it. I believe in you full-heartedly. Okay, so nothing down. I have to turn my propulsion back on. Oh my god, these dogs, I swear. Okay. Right, so I'm in a different part that I haven't gotten to yet. It does not look like I'm going to need... Damn it! I need Sue spores. Yep. Stop there. I need Sue spores. Ooh, yay. Maybe I can get some Sue spores over here. Hopefully I can. That would be nice. No, but I got a weird-ass fungal tissue. No, I was the only one over here? Okay. So what I'm gonna do is I'm gonna call in the droid. Drone, that's what he is, not a droid. And then... Canopy root. And then whatever the hell you are. Let's see. Sample already analyzed. Oh, yeah, that's because I was using it for stuff. Fungal cluster. Sing stock taxonomy entry updated. Alright, sweet. Let's talk about some sing stocks. Ooh, and table stocks have been updated. Theories. Attempts to analyze the interior of a sing stock reveals many different organisms within the stock which are not genetically related to it in any way. It seems that the sing stalks are actually tubular gardens which host juvenile fungal creatures. The swaying of the stalks keeps these sealed environments fed with filtered water and microbial life, while allowing their spores to be distributed across the reef. However, I haven't found a single example of any of these life forms growing outside of a sing stalk, suggesting that they can only survive within these carefully controlled tube gardens, and that the spores they release are being used by the stalks for other purposes. Are these vertical farms designed to cultivate other species that might feed the rest of the stalks with showers of nutrient-rich spores? Ooh. Alright. Table stock. Behavior. Okay, who is crying and why? It's annoying me. Analysis of a table stock root shows a number of minerals not associated with stock growth being extracted from the bedrock. Due to the table stock's need for these minerals to survive, or Do these table stocks need these minerals to survive, or are they using them for some other purpose? A cross-section of the root shows a central chamber typical of the carbon transfer system seen in other stocks. But unlike those stocks, table stocks have many subsidiary chambers, like a bundle of wires, each carrying a particular cocktail of mineral compounds. These secondary roots are not drawing up large amounts of these materials, just traces. But why? Perhaps there is some connection to those growths in the upper canopies of the table stalks? They are well secured by the stalk's tight binding, but perhaps we can find one that has been dislodged. Alright. Alright, so... Oh my goodness! I need to get some Sue spores. So let me see what I have. Do I remember what they look like? No. Oh wait, here they are. Okay. Just take one for now. Alright, I have show sex. I should have show sex, yeah. Alright. To turn on my propulsion. I just can't go through there? Well, that's dumb. So, why can't I go through here? Beyond these thickly entwined is a violent current that can be heard rushing down through the gap in the headland. Okay. Fungal creatures which communicates to... Okay, I guess I'm going this way. I just wasted a propulsion for nothing. Sampling of what? Fungal cluster. Oh, Jesus. Wasted 2 propulsions. Let me top off my oxygen. So I'm going to be using that a lot. Why are we no longer doing the thing that we need to do? I'm about to piss that thing off. Okay. Okay. This is what I need. That's what we needed. Ooh, fancy. And to purport out of here. Good lord. Okay. This is where we started. Now there's nothing else. But there might be something down here. I don't know if I got shrill sacks all the way down here. No, these are stock spores. So let's talk to the drone. It'll make this a little bit easier. So I want to get a better look at that map. Okay. Alright, so I only have 2 left. And I'm just not entirely sure how to get to that one. Because this is the thing, right? And then there's like this thing. I don't know if there's a way to get over there. Not that one. Sir? I said not that one. Lab analysis complete. Reef cap taxonomy. Entry updated. Taxonomy! Reef cap. With theories. Analysis of reef cap tissues show that the reef caps maintain a bacterial symbiote within a series of internal chambers, which, while unique to the Galease 667cc, resembles Epolopsism, a large-celled bacteria found in the stomachs of terrestrial surgeonfish. Terrestrial surgeonfish. I guess it just means earthen, or from Earth. Epolopsism helps surgeonfish break down algae effectively, and the reef cap's bacteria seem to do the same, with traces of algae-like growths found in the cap's chambers. Where is the algae coming from? However the caps receive it, this algae is allowing the caps to grow bacterial colonies, which then reduce themselves to endospores when the algae is digested. When these endospores are then released by the stalks in the local area to renew the strength of their colonies. It's an incredible recycling system, but for protecting this ecosystem. And then the sketch. Fascinating. Okay. I guess. So I really want to figure out what this is, but I don't think I have the ability to do that yet. On the reef's middle finger, there's a forest. I wonder if... Hold on. I might be able to figure this out. Okay. It's right over there, right? I can probably just propel myself over. Okay. This is where I would need a sooth spore, wouldn't it? Probably. I have not. Yeah. Okay, can I get a sooth spore? Probably down below. Oh, I can't go back over there. But can I can if I do this. No, I don't need that. Please be a shrill sack. Ugh. Man, I'll take it. Okay. Okay. Are you Sue spores or shrill sacks? Shrill sacks. Yay. Okay. Come on. Thank you. Back to 20 meters. Alright, now to go over here.